two exponential functions are here. We need to think about logarithm of both sides. Let's try to get, what about logarithm? 10 to the x minus x squared is equal to logarithm x above x. Of course, if we use the features of logarithm here, our operations will be easier. Let's remember this feature immediately. Logarithm base a to the b equals. We know that b times logarithm base a is, and also the expression here, 1. To solve the problem by using, we can continue, x minus x squared times logarithm 10 is equal to x times logarithm x. Now, one of the general features of logarithm, again, us logarithm in base fx. If gx is given as this gx function is greater than 0, x is greater than 0. And we know that f of x is not equal to 1. In this case, what can we use in this question? X is definitely greater than 0. Then we can use it. If we continue, I think what else can we do? With this feature, we know that this is equal to 1. Then what happened? X minus x squared is equal to x times logarithm. We have come to position x. Let's throw this friend across now. Let's see what will come before us. X minus x squared minus x times the logarithm x. We have one equation equal to 0. I ask you for this video, you can stop and try to solve it yourself. If you could solve the question with different methods, please comment. I'm very curious that you watched it. Please specify in the comments. Can be asked in school exams and the Olympics. You may come across more difficult than that. Now I think, what can I do after here? Look at the expression here. Let's get an x bracket and see what comes next. 1 minus x in x bracket. We get minus x times logarithm x is equal to 0. If you pay attention, there is an x here. There's an x here too. Then the common factor, I can continue this question by taking the bracket. If I get x common multiplier bracket, what will be left? We have 1 minus x minus logarithm. We get the equation equal to 0. What does it mean if this result is 0? Means x is 0. Or 1 minus x minus logarithm means x is 0. The definition of logarithm. What did we accept in the first place? Look, we didn't accept more precisely because of our feature. We said it was like this. Then what can I say here? So because x is greater than 0, I can't use this feature, that is, the part here. Then where should I focus? I need to focus on the other side. Of course, I think, what can I do here too? If we continue, this friend 1 minus x. It would be great if we expressed it as log x. Now, what am I going to think here? Of course, look, if you pay attention, if we call this fx function and this, if we say gx function, one is logarithmic and one is normal polynomial. Came across as a function. I can't find the solution sets of them directly. About their graphics. Let's make some comments. Let's draw a coordinate axis from the coordinate axis. So let's see what he says to us. Let's move accordingly. Now it will be the fx function I drew in blue. If I want to draw this, of course it happened like this. Here became 1, here became 1. If I want to draw the logarithm function, let's express it in red. Of course it's fx here. We need to say, if we express it in red, this will come from below. It will pass exactly where the 1 is. What can I say to this igx function? The point where these two intersect is actually 1. I really found it. So about him right away. Let's go to a solution. So x is equal to 1 is really the solution to this. If we focus on 1 equals logarithm 1, 0 equals logarithm 1, we already know what it is. Logarithm, base 1 and logarithm 1. Is equal to 0. We know the features of logarithm. Then this question, the only solution is only available at one point. As I said, 1 is a polynomial function. The logarithmic function, because it would be better for us to express it with graphics. If you have one other solution method, please comment. Don't forget to write, like the video with your friends. Very nice if you share it with your friends, and I will be pleased. See, you stay with math. Bye-bye.